Hi everyone, in this video we are going to cover the principle of inclusion and exclusion. Basically this is the counting technique that is helped to find the number of elements in a group that are overlapped. For example, if we have two sets A and B, how to count the number of elements in a union? So generally when we have the two sets, what we are doing, we are counting the total number of elements in a set A and B, then we are subtracting this intersection because it get have counted twice. So number of elements in a A union B is equal to the number of elements in a A plus number of elements in a B minus number of elements in a A intersection B. And this represents the cardinality of the set. Cardinality of the set means it is a number of elements in a set. Similarly, if we have the three sets, we can also count its union with the help of the count of elements in a set A, B, C, subtraction of intersection of A and B, intersection of AC, intersection of B and C sets, and then we will add intersection of all these sets. From here to here, you will get the pattern. In starting, we are taking the one set at a time. Next time, we are taking a negative sign and two sets at a time with intersection. And after that, we are taking a addition with three sets at a time with intersection. Similarly, we can write this formula for the four sets. Suppose you need to calculate the union of four sets A, B, C, D. So this is calculated as number of elements in a set A, B, C and D minus take two sets at a time, that is A intersection B, negative of A intersection with C, then A intersection with D, negative of then B intersection with C, negative of B intersection with D, then last is C intersection with D. After that, we will change the sign. Here we have considered the plus and then we have taken negative. Now we will take the plus. Basically, we are taking the alternative signs. And we will take three sets at a time. So starting with A, B and C sets with intersection plus. Then instead of C, we can take D. Now instead of B, we can take set C. So these all are the combination with the set A. Now last combination we have B intersection C intersection D set. Count the elements in this case. And the last we have take all these sets at a time with intersection. So here we are taking the cardinalities of each set and this union is calculated with the help of this formula. To understand better way, let's take this example. Here we have taken, there are 345 students at the college who have taken the course in a calculus, 212 who have taken the course as a discrete mathematics, and 188 who have taken course in both calculus and discrete mathematics. Now we need to calculate how many students have taken a course in either calculus or discrete mathematics. As per this one, first collect the data. Let A represents the students who have taken a course calculus, whereas B represents those students those who have taken the discrete mathematics. So as per this question, we have the total count of the set A, that is 345, and the number of students in a B set is 212. As per this, we have A intersection B, that is equal to 188 because we have taken the students, those who have taken the calculus as well as discrete mathematics. It means that is the intersection. As per this question, we need to calculate how many students have taken course either calculus or discrete mathematics. It means we need to calculate A union B count. So that is calculated with the help of principle of inclusion and exclusion, that is number of students in a set A plus number of students in a set B minus number of students in a A intersection B. Plug in these values here. We have 345 plus 212 minus 188, and this is equal to 369, and that is the final answer in this case. Taking the next example, how many positive integers not exceeding 1000 are divisible by 7 or 11? So let's suppose A represents the positive integers not exceeding 1000 are divisible by 7, and B represents the all positive integers not exceeding 1000 and are divisible by 11. There are many ways to calculate this count, but we have actual formula in this case as well. So before directly jumping to the formula, let's understand that how we can construct that formula. So suppose we have first 50 numbers positive integer. We need to find how many positive integer not exceeding 50 are divisible by 2. So that is 25. Now how many positive integer not exceeding 50 are divisible by 3? That is 16. How many integers not exceeding 50 and divisible by 4? That is 12. Now how we are getting? So when we divide 50 by 2, we are getting exactly 25. And when we divide 50 by 3, we are not getting 16. Basically, we are getting 16.666. And in this case, when 50 is divided by 4, we are getting 12.5. In this case, we are discarding the decimals and we are taking this integer 16 and 12. Basically, here we are using one function. As everyone knows that this function indicates the step function or the greatest integer. And in this case, if I write 3.6, this will give us 4. And if we have 3.2, the greatest integer gives the value as 3. Similarly, we have two more functions. One is called as the floor function. Another is called as the ceiling function. Floor function is represented by this form and the ceiling function is represented by this form. Floor function basically gives us the largest integer that is less than or equal to the given number. So we need to find the integer that is either is equal to this or less than to this one but greater than all other. Means when we apply floor function on this, we are getting the integer as 16. Even floor over the 16.11, that is also is equal to 16. Whereas if we apply the ceiling function on 16.66, this will give us 17, and 16.11, this also gives us the next integer as the 17. So in this case, we are using the floor function. So with the help of this, we can evaluate this. Positive integer not exceeding 1000 are divisible by 7, that is calculated as 1000 by 7 and then take floor. Similarly, we can count the number of positive integers not exceeding 1000 and divisible by 11. In this case, we have 142.85, then take its floor, that is equal to 142, and here we have 90.90, that is equal to 90. Now we need to count the numbers that are divisible by 7 or 11. Basically, we need to count A union B. That is equal to the number of elements in a set A plus number of elements in a set B minus number of elements in a set A intersection B. This count is equal to 142. plus 90 minus number of elements in A intersection B means number of positive integer not exceeding 1000, that is divisible by 7 as well as 11. So we can count this as is equal to 1000 by number is divisible by 7 as well as 11. So we will do the product in this case and then we will take the flow. So this is equal to 12. Substitute here and finally we are getting a value in this case as 220. Another example we can take it as find the number of positive integer not exceeding 100 that are not divisible by 5 or by 7. What we need to do, first we need to find what is the count of A union B and after that remove that count from the 100. That will give you the final answer. Try this question by yourself and answer this question in a comment section.